All right, in this video, we're going to go through the 2021 numbers 1 through 3 free response. Homework would be 4 through 6. Those are all no calculator ones for homework. So to estimate the f prime of 2.25, the best we can do is an average rate of change from the table. So do your change in y over change in x using the points on either side. So the f of r was milligrams per square centimeter. So when we do this average rate of change, it became, milligrams, per square centimeter. So you can either do milligrams per centimeter squared per centimeter, or it could become a centimeter cubed for your units. Now, the meaning of this is what we were, first off, it's a rate of change. And the thing that's changing is the density. So it's a rate, the density is increasing in this case at 2.25 centimeters from the center. All right, looking at part B. So they said we had the integral of 2 pi, and then in the integral is r times f of r. So this is kind of a unique one in terms of a Riemann sum, because it's not just the base times the height, you're also multiplying by the r. So our 4 intervals here, so our delta x is 1, so that's what this is, that delta x. The height is 2, so that's the y value. And then the radius, you're taking the radius from the right edge, so that radius is 1. When we go to the next one, we're going here. The delta x from 1 to 2 was 1. The right-hand height, the y value is 6. And now the radius we're using is 2. And then you're doing that for each of them and multiplying by 2 pi. So you either have it in terms of pi there or 2 3 decimal places. F of r was increasing, so therefore this integral would be an overestimate. So you can see in the picture there, our rectangles are going to have a little bit more than the actual area under the curve. And then the last part for D, so g of k would just be the g function they gave us with k filled in for r. That's on the left there. And we want to know what value of k is that equal to the average value of g on the interval from 1 to 4. Well, average value is 1 over b minus a. So 1 over 4 minus 1 gives us the 1/3 out in front on the right there. And then it's just the integral from 1 to 4 of the g function that they gave us. And you're just going to solve this graphically. So the right side, when you put it in a graphs page, it's just going to give you a constant because that's going to be just a number. On the left, just make sure to put x in instead of k, and then you're just finding that intersection. The k is our x value, so just keep in mind that's what we want for our answer, and just round it to 3 decimal places. Going over to 2, we want the speed. Speed is square root of x derivative squared plus y derivative squared. And we'd be filling in 1.2 in this case. So you get the 1.271. They had already given us the x and y derivatives. Keep in mind, you got to make sure you're in radian mode because we do have trig in that one. Total distance traveled, that's the same as saying our arc length. So that's integral from 0 to 1.2, and then it's a similar setup to speed, just you're not subbing the 1.2 in for the t, you're leaving it as t's, and you get 1.010 to 3 decimal places. Furthest left is when the x part has a minimum. So first find your critical value for the x part, put the x velocity equal to 0. The exponential part will never equal 0. The t minus 1 will equal 0 at 1. Well, once you have that 1, again, the exponential part's always always positive. So the t minus 1, just think of the line t minus 1. It's a positive slope increasing from left to right. So left of the 1 is when it'll be negative, right of the 1 will be positive. And we got our number line there. T equals 1 is the minimum since x prime of t switches from negative to positive. That guarantees we have a minimum. And that's all we wanted for, let's see. So it looks like actually I need to So once we have the t equals 1, we're then going to do an accumulation function because they told us the point that we knew for the particle was -2, 5. So we know that x is -2 at t equals 0. So start with the y value we know, and then the accumulation function will go from the x we have, or I guess the t we have in this case, to the t that we want to go to. And adding that on will give us how the x part has changed. And then for the y, we know the y value of 5, and then our t's are going from the 0 that we knew to the 1 where we know it's going to be the minimum, and then just put those in and round it to 3 decimal places. Now this is one that's easy to miss. There's a second part. So remember, always in a free response, reread each of the parts when you think you're done. They also want us to tell why there's no point furthest to the right. Well, from our number line, notice that right of 1, we were always going to have a positive rate of change, meaning that distance to the right was just going to keep increasing for the entire time that t was greater than 1. And for the last one, for 3, we've got this graph here. They said it's going to, when it's spun around the x-axis, is representing a spinning toy. So first one, c is going to equal 6, and they just want us to find the area. So area is integral of top minus bottom if you're in terms of x. It's integral of right minus left if you're in terms of y's. So we basically have 6 filled in for c, and it's function minus 0. To do that, you see over on the left there, we had to do a little u substitution with a correction. Change your bounds, do your antiderivative and sub in. We should have got 16 inches squared for that area. For part B, we want to find the value of C that's going to have the largest cross section of the slice being 1.2. Well, that cross section 1.2 is the same as the y value because it's the amount that's coming up from the x-axis. And notice they also give us the derivative there. So what we're going to start out with up in the top left here, put that 1.2 in for the y value and work to get c by itself. Then what we're going to take is we're going to take that value of c and we'll fill it in for c in the derivative equation. And we'll set that derivative equal to 0. Because 1.2 is a maximum, it should have a derivative value of 0 at the maximum. So if you neaten this up, basically the square root in the denominator multiplies the square root in that little fraction, so it just becomes 4 minus x to the first. We'll set the numerator equal to 0, because a fraction is 0 when the numerator is equal to 0. And we got x is equal plus or minus radical 2, but they told us that c was a positive constant. So we're going to go back to this value of c here, and we're just going to sub in for x, the square root of 2. We'll neaten it up, and we get that when c is 0.6, that's when that y value is going to be a maximum. I feel that part is a little bit of a tricky question. And then the last one, when we spin the toy around, the volume is 2 pi cubic inches. Well, a region was completely flush against the x-axis, so this is a disks. Disks is pi integral whatever our radius is squared. So to get that radius, we do top minus bottom, so it's function minus 0, and that should all equal 2 pi, it said. So we could divide the pi over. I chose to pull the c squared out front. So then I just had x squared times our expression 4 minus x squared because the radical got wiped out. So you can just distribute the x squared, and then it's just a polynomial you're doing the antiderivative of and subbing in. Eventually you get square root of 15/30 seconds, or something equivalent to that if you chose to rationalize. Again, technically that c would have a plus minus out front, but they told us that c had to be a positive constant, so our final answer should just have positive square root of 15/30 seconds. For the remainder of the period, you are going to start working on the homework, which is the next set of 3 free response ones. You can be communicating and working with the people in your groups. And remember, those should be no calculator questions.